Hi guys, it's Miss Griffin. We're taking a look at the last skill in Unit 8. Woohoo! Unit 8, Skill 6 says proving triangle type. So in last video we were proving quadrilaterals, four-sided figures. This time we're going to use four-sided figures to prove that it's a certain type of triangle, whether it's a right triangle, isosceles, equilateral, so on and so forth. So we're going to use the properties of the given shape to get us the shape we need. Use properties of given shape to get the shape you need. So in example 1 it says that we know that ABCD is a rectangle. So off to the side I'm just going to take a second to brain dump anything I know about rectangles. So maybe the basic thing is that opposite sides are congruent and parallel. I know that there are 4 right angles. And then let's think about diagonals. There's 2 really important properties about the diagonals of a rectangle. So that would be BD and AC. What do you notice about them? Hopefully you're noticing that they bisect each other, they cut each other in half, and that they're congruent. Then I'm going to take a look at the isosceles triangle and recall what I know about isosceles triangles. Isosceles triangles. Isosceles has 2 congruent sides and angles. Okay, so I'm going to outline my isosceles triangle in yellow so that I can figure out what I'm going to have to do in order to get this triangle to be isosceles. You could do the T-chart proof like you see here off to the side, statement and reason, but I'm going to do just because statements. So whenever you hear me say the word because, that's when you jump over to the reason side. And I'm going to color code it so if you are doing T-chart proof, then you'll be able to match your parts up appropriately. So, I need to get this triangle isosceles, which means that I need 2 sides congruent, being AR and BR. So to me, those segments lie along the diagonals. So I'm probably going to focus on these 2 diagonal properties. I might need one, I might need both. I don't really know until I get going. So now I'm going to start by drawing my T-chart proof if that's what I'm choosing to do, or start just by writing my given. ABCD is a rectangle because given. Step 2. I'm going to start by saying that the diagonals are congruent to one another. AC is congruent to DB. And that's because a rectangle has congruent diagonals. Okay, so now I got to figure out what does that do for me. I know this piece is congruent to this piece. Your picture gets a little bit messy. But also recall that the diagonals bisect each other. They cut each other in half. So if I take a segment, say AC, and then I take a segment BD, and I say initially this is 10 and this one's 10. And I know that they bisect each other, meaning they cut each other in half. So that 10 now becomes split up into 5s on each of them. So if the diagonals bisect each other, then I know, and they're congruent by the way, then I know that every single piece, AR is congruent to CR, which is congruent to DR, which is congruent to BR. Because remember again, we took those 10s from both congruent diagonals and split them in half, 5, 5, 5, 5. So we're going to say AR is congruent to CR, is congruent to BR, is congruent to DR. And I'm going to mark that on my picture in red. This piece is congruent to this piece, which is congruent to this piece, which is congruent to that piece. And again, it's because the whole diagonals AC and BD were congruent to each other. So when we cut those congruent parts in half, we get 4 congruent parts. Kind of like what we talked about in the video last time. Because diagonals bisect each other in a rectangle. Now I think last time we said something about a bisector divides 2 congruent segments into 4 congruent segments. You could say that also in this, but you have to make sure you mention in a rectangle, because that's the shape that we're talking about here. So if I look at my diagram, it looks as though I have AR congruent to BR, making this yellow triangle ARB an isosceles triangle, because there are 2 congruent sides. So if I just look back at my proof, it says that AR is congruent to BR. So step 4, I think I'm ready to prove. Triangle ARB is isosceles because there are 2 congruent sides. And you can end it there. You don't have to say and angles, and in fact you shouldn't say and angles because we haven't shown that the angles are congruent. If we had an added step in here talking about how angle RAB and RBA are congruent, then we could say congruent sides and angles. But we didn't, so I'm going to back that train up and erase that arrow. Okay, so this is our first proof using the properties of a rectangle to prove that we have an isosceles triangle. On the next page, we're going to use properties of other quadrilaterals to prove isosceles and right triangles. So the proof is a little bit longer, but it's not hard or more difficult. All right, so flip it over. All right, so you can tell that this one comes right out of an exam. It says number 35, given quadrilateral ABCD with diagonals AC and BD that bisect each other. So they start us with a 4-sided shape that has diagonals that bisect each other. So you need to be thinking that this turns it into another shape. Because as soon as we take any random 4-sided figure and then change it so that the diagonals cut each other in half, it now is no longer just a 4-sided shape. It's now a parallelogram. And that's important to keep in mind because remember last time in 8.5 we said if they don't give you a parallelogram, you have to prove that it's a parallelogram first. And then you get to go elsewhere after that. So then if I take and continue reading, it says that angle 1 is congruent to angle 2. So I'm going to mark that up in my picture. And I'm like, oh, wow, wait a second. This parallelogram has angles that are congruent from a given angle in the parallelogram, meaning a full angle is cut in half, meaning this diagonal that's right here bisected an angle. Ooh, what kind of shape has bisected diagonals and bisected angles? Get thinking. Bisected diagonals and bisected angles. That is a rhombus. So because we have a parallelogram that turns into a rhombus, we need to state both of those things. But let's look at our goal, see what's happening. I'm just going to erase some of these markings on here because it is going to get a little bit crazy. You are going to want some colors to outline or highlight. It says that prove triangle ACD is isosceles. So I'm going to find that and outline it in yellow to match the box that I just drew. I want to prove that this is isosceles. So I'm going to, again, write myself a note. What do I know about isosceles triangles? 2 congruent sides. And so now the other part says that we want to prove that it's a right triangle, triangle AEB. So I boxed that in a different color and I'm going to outline it in a different color on my picture. I want to prove that that's a right triangle. All right, so let's get going. I'm going to choose to, again, do because statements. So I have statements will be in blue and my becauses, my reasons will be in purple. So if you choose to do a T-chart proof, again, you should be able to follow along with me. So step 1, I'm just going to do some dots right now instead of writing the whole given. But again, trust me, on a test you have to write the entire given. So then we have because given. Step 2. Remember I said that because the diagonals bisect each other, we need to talk about the fact that the whole quadrilateral is not anymore just a quadrilateral, but now a parallelogram. So we're going to say that ABCD is a parallelogram because diagonals bisect each other. And then I also said, well, wait a second, it's not just a parallelogram because it has an angle that's being cut in half to create two congruent angles. So ABCD is a rhombus. And this is because a parallelogram with diagonals bisecting an angle is a rhombus. And if you're struggling to figure out why it's a rhombus, it's because we're bisecting angle A into two congruent angles. You don't have to write that, but it might just help you to understand it a little bit better. So now we need to think about properties of a rhombus and how it might get us to the fact that we have an isosceles triangle. So a rhombus, remember, is like a tilted square. And a square looks like this. A rhombus looks like this. Hopefully a little bit better than that. Probably it looks like the one that's in the picture since it's a rhombus anyways. So a rhombus, if you recall, has 4 congruent sides. So we're going to state that here and then maybe it'll help us. We have AD is congruent to CD, which is congruent to CB, which is congruent to AB. And this is because a rhombus has 4 congruent sides. So I'm going to look back at my picture again and see if that helped me at all. My yellow triangle is supposed to be isosceles, meaning 2 congruent sides. And I just marked AD congruent to CD, and I stated it right here, AD congruent to CD. So that means that we now have an isosceles triangle. Step 5. Triangle ACD is isosceles because there are, and this is where you just state the properties, 2 congruent sides. And I'm going to box that in yellow to show myself, yeah, buddy, I proved it. But don't forget there was a green box. And we have to talk about that green box because I guess we didn't finish really talking about the properties of a right triangle. A right triangle has a right angle. And right angles come from what kind of lines? Perpendicular. So now we need to think, okay, what else might I know about a rhombus or a parallelogram that will help me prove that this triangle is a right triangle? So I feel like I remember something about the diagonals in a rhombus, besides the fact that they bisect each other, because remember, that comes from a parallelogram. These diagonals look as though they're perpendicular, right? We could draw right angles in every single one of these spots, which would be super helpful if I could draw a right angle in that green triangle. And so it is true that we have diagonals that are perpendicular, so we need to state that first because it's not explicitly stated. Yes, we have a rhombus, but it doesn't say that AC is perpendicular to BD, so we have to state that. AC perpendicular to BD. And that's because diagonals in a rhombus are perpendicular. Now that we have perpendicular lines, we can easily state that that angle is a right angle. So angle AEB, or you could put the number 1 in there, or not number 1, I'm sorry, 1 is already used, 1, 2, and then 3, angle 3. So step 7 would be to say that angle 3 is a right angle? Because perpendicular lines make right angles. And if you're like, wait, Miss Griffin, you didn't put congruent in there. Perpendicular lines make congruent right angles. You're right, I didn't put congruent in there because I'm not saying angle 3 is congruent to anything. I'm just saying it's a right angle. All right, so now we have to pull ourselves back. We said that we need triangle AEB to be a right triangle, and we just said that we have a right angle within that picture. Right, angle 3 right here, messy as can be. Angle 3 is a right angle, so that means that this green triangle, AEB, is a right triangle. So we're on to our last proof statement, step 8. Triangle AEB is a right triangle. I'm going to box that in my green marker real quick to match what I did up above, and then I'm going to say because there is a right angle. So when you guys get to your practice problems, remember yesterday you were not supposed to take the CFU yet. You're waiting to do the CFU until you finish your practice for 9.5 or 8.5 and 8.6. When you do the practice problems, I can almost guarantee that none of them are going to be exactly like this. So you are going to have to stretch your brain, use a little bit of thinking in order to be successful on the practice. So think about properties that you know of. How can you get from a quadrilateral to a certain type of triangle, and just use your brain for that time that you're working. Because some of you guys don't persevere. You just say, oh no, I don't know how to do this, I'm done. So you guys got to have a little bit of grit, some perseverance, and some thought processing in your brain. Okay, you guys are all capable, you just got to think for a little bit. If you have questions though, feel free to reach out to your teacher. And then after you finish practice for both of them, that's when you're going to take the CFU. And the CFU will either be on a quadrilateral, proving a four-sided figure, or on a triangle, proving a three-sided figure. Okay, so you don't know which one's coming at you, that's why you got to practice both of them. All right, good luck.